The essential thing to realize with phasors is that we want to find a way to represent a sinusoid more compactly. Because the current way that we've been drawing sinusoids versus time has been looking something like that. How many points are needed to draw this sinusoid perfectly? TJ?
Is it 6 or 7? Just for each time it crosses.
Well, how many points did I draw here to draw the sinusoid?
9.
Okay, so if I drew 9 points, it might look like this. One, two, three, four, 5, 6, 7, 8, 9. Does that completely draw the sinusoid?
No. Well, to completely draw it, you need an infinite amount of points.
You really need an infinite number of points. So in the time domain, which is the only way we've talked about drawing sinusoids before, it's any function of time is really composed of an infinite number of points. But TJ, I understood what you were saying before, earlier. How many unique characteristics are there do you need to specify using polar notation to specify this sinusoid?
As many as possible.
Well, now I'm not talking about in the time domain where you need to have an infinite number, but I'm saying going back to what we talked about on this screen, how many points were necessary? How many different numbers were necessary to fully specify a sinusoid?
Well, for the rectangular, it's 1.
For the rectangular, it's 1?
It's well, 1
there's
point.
A, certainly.
Well, wouldn't it just be kind of 2 numbers in theory? Because your A
It's
and B, because your A and B is already used up. So
and then what else do you need?
Your C and angle phase or
So in rectangular, it's A, B, and omega. And then how many is it in polar notation?
just C and your angle.
C and your angle.
C, angle, and also your omega, right? So either way, you need 3 numbers to fully specify what this is, which makes sense.
Wait, how come you're omega? Sorry, like why your omega?
Why your omega? Well, maybe it's easiest to give an example. 3 cosine of 7t minus 4 sine of 7t. Kyle, tell me how you would represent that using only 2 numbers and not having your 7.
No, I meant for the polar notation of it.
Okay, so let's try the polar notation. Tell me how you would represent this using only 2 numbers and not 3.
Oh, I have my C value, and then which is 5, and then
So you'd keep your 5.
Yeah, and then for amplitude value, and then I just take the angle phase, and I
take your angle, and you wouldn't. And so you're saying that this is the exact same waveform as that. There's no difference between these 2 things.
No, there clearly is a difference. I'm just
clearly there is. So you need that extra number. This 7 matters. So just like there's 3 different numbers with rectangular, there's 3 different numbers with polar. In general, there's always 3 numbers. In general, there's going to be omega plus there's going to be 2 others. And what those 2 others are depends upon if you're in rectangular or polar. If you're in rectangular, it's A and B. And if it's in polar, it's C and theta. Okay. So now, given that, let's, TJ, go back to this question and tell me what's the minimum number of numbers you actually need to represent this thing if you're not in time domain, just as numbers.
Is it 3?
Just 3. And it's always going to be, you only need 3 numbers. So if there's a different way that we could draw the sinusoid, not in the time domain that requires an infinite number of numbers, but in a different domain, we might be able to get by with just 3 numbers. When we're working with phasors, we're always assuming a constant phase. So I'm going to take omega out of that equation, and we're just going to have to remember what our omega is. And if I take my omega out, now we're down to just 2 numbers. And instead of saying I'm always going to draw it with an A and a B value, or I'm always going to draw it with a C and a theta value, 2 different ways we could draw this point. I'm instead going to pretend that this axis is a real part. This axis is an imaginary part. And I'm going to instead pretend that this is a complex number z. And it has a real part of A. It has an imaginary part of B. You could alternatively say it has a magnitude of C at an angle of theta. But either way, we're going to graph it as this. We're going to think of it, this entire sinusoid, as a single complex number, which we could graph as A plus JB, or we could graph as C at an angle of theta. They're both equivalent. But now we've reduced this entire sinusoid's infinite number of points to a single complex number. Whoa, that is a phasor. So a phasor is just a representation of a sinusoid as a single complex number.
So you could just entirely ignore the parts of the amplitude, or like the corner parts of the amplitude where
You haven't
rises
ignored the
up.
amplitude at all.
Well, I
The
know,
amplitude is C.
no, I understand it, but like when it rises up to its maximum point and then it finally falls down, there's a curvature in between those areas. You can just entirely ignore that.
So you're right. You're talking about the omega. And so a phasor is a representation of a sinusoid as a single complex number. And then in small little typeface, we'll add at some sort of given frequency.
Okay.
And let me give an example of what this looks like.